Hi friends, welcome to my channel. Before going to the video, those who are not subscribed our channel, subscribe it and also click the bell button. In this video, we are going to see about Thevenins theorem. It is an analytical method used to change a complex circuit into a simple equivalent circuit consisting of a single voltage source in series with a resistor. The Thevenins theorem states that a linear two-terminal network consisting of several voltage sources, current sources and resistors can be replaced by a single voltage source in series with single resistor. This voltage source is called as Thevenins voltage and the resistance is called as Thevenins resistance. This Thevenins theorem is especially useful in analyzing power systems and other circuits where one particular resistor, that is the load resistor, is subject to change. Now let us see how to find the Thevenins voltage. First, identify the target element across which the Thevenins voltage has to be determined. Then find the open circuited voltage across the terminals. This voltage is the Thevenin voltage. Next we have to find the Thevenins resistance. For that, identify the target element across which Thevenin resistance has to be determined. Remove that target element and find the equivalent resistance across the terminal by removing all the power sources in the original circuit. That is, we have to short circuit the voltage source and open circuit the current source. If any internal impedance is given, we have to replace the voltage source and current source by their internal impedance. So this equivalent resistance is the Thevenin resistance. And one important thing you have to remember is that if there are no independent sources present in the network, then the Thevenin voltage is equal to 0. Now let us understand the Thevenins theorem by using a problem. Here they have asked to find the current through the load resistor RL using Thevenins theorem. Here the source voltage is 30 volt and there is an independent source current which is equal to 2 amps and resistance value R1 is equal to 3 ohms, R2 is equal to 3 ohms, R3 is equal to 3 ohms and load resistance is equal to 5 ohms. So the options are A 1 amps, B 4 amps, C 2 amps, D 5 amps. So here the answer is 4 amps. So let us see how we will get this. First step in Thevenins theorem is to find the Thevenins voltage. For that we have to open circuit the load terminal and find the voltage across it. For that, let us apply KCL, Kirchhoff's current law, so which states that the algebraic sum of currents at any junction or node is equal to 0, or the algebraic sum of currents entering the junction is equal to algebraic sum of currents leaving the junction. Here the entering current is 2 amps and the leaving currents are VTH minus 30 divided by R1 plus R3 plus VTH by 3. Now VTH by 6 minus 30 by 6 is equal to 5 plus VTH by 3 is equal to 2. So moving minus 5 to our right hand side, we have VTH by 6 plus VTH by 3 is equal to 7. So simplifying, we have VTH is equal to 14 volt. Next step is to find the Thevenin resistance. For this, we have to short circuit the voltage source and open circuit the current source and find the equivalent resistance across the open circuited load terminals. This gives the Thevenins resistance. So RTH is equal to R1 plus R3 because these two are series parallel with R2. So RTH is equal to 6 into 3 divided by 6 plus 3, which is equal to 18 by 9 is equal to 2 ohms. After finding the Thevenins voltage and Thevenins resistance, we have to draw the Thevenins equivalent circuit. And after that, include the load resistor in the circuit. Now we can find the current flowing through the load resistor by using the formula I is equal to VTH divided by RTH plus RL. So VTH is 14 volt divided by RTH is equal to 2 ohm plus load resistance is 5 ohm. So we have got the current through the load resistor as 2 amps. Let us see the previous year questions next. First question, a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source Vt in series with a resistor Rt, where Rt is the ratio of. This question was asked in June 2014 and the options are open circuited voltage to the short circuit current at the terminal pair, short circuit current to the short circuit voltage at the terminal, open circuit voltage to the open circuit current at the terminal pair. The independent sources are turned off. So the options are 1 and 4, B 2 and 4, C 3 and 4 and D 2 and 3. We know that in Thevenins equivalent circuit, open circuit voltage to short circuit current is the Thevenins resistance at the terminal pair. So, and we are turning off all the independent sources. So option A is correct. Next question is, which equivalent circuits are dual? This question was asked in December 2014. So the options are Norton and Thevenin, Thevenin and superposition, Norton and Thevenin, Thevenin and Millman. We know that Norton and Thevenin circuits are dual because in Thevenins we have voltage source in series with resistor, and in Norton's we have current source in parallel with the resistance. So option C is correct. Next question is, in Thevenin equivalent circuit, which is incorrect? This question was asked in December 2014. The options are independent voltage sources are open circuited, independent voltage sources are short circuited, dependent voltage sources are removed, current sources are opened. We know that we have to short circuit the independent voltage source and open circuit the independent current source. So option A is wrong. Next question is, for the network, find the Thevenins equivalent resistance, that is RTH. This question was asked in December 2014 and here given the circuit as, here the voltage source is 1 volt and current source value not given. So the resistance are 4 ohm, 4 ohm and 2 ohm and 2 ohm. We have asked to find the Thevenin resistance across the terminals A and B. Options are 2 ohm, B 3 ohm, C 4 ohm, D 6 ohm. So the answer is B 3 ohm. Let us see how we got this. First step to find the Thevenin resistance is to open circuit the current source and short circuit the voltage source. Now the resistors 4 ohm and 4 ohm are parallel, and also the resistors 2 ohm and 2 ohm are also parallel. But these two equivalent is in series with each other. So Thevenin's equivalent resistance is 4 ohm parallel 4 ohm plus 2 ohm parallel 2 ohm. Now RTH is equal to 4 into 4 divided by 4 plus 4. We know that if two resistors are parallel and they have same value, the equivalent resistors will be half of that. So For 4 ohm parallel 4 ohm we have 2 ohm, and for 2 ohm parallel 2 ohm we have 1 ohm. So 2 plus 1 we have 3 ohms. So Thevenin's equivalent resistance is 3 ohms. Next question is, find the Thevenin's equivalent across the given terminals A and B. This question also asked in December 2014. Here they have given two independent voltage sources, 6 volt and 12 volt, and two resistors each of 2 ohms, and they have asked to find the voltage across the terminals A and B. The options are 6 volt in series with 2 ohm, 9 volt in series with 1 ohm, and 12 volt in series with 4 ohm, and 18 volt in series with 2 ohm. Here the answer is option B, 9 volt in series with 1 ohm. Let us see how we got this. First step is to find the Thevenin voltage. For that we have to find the open circuited voltage across the terminals A and B. This is VTH. So applying Kirchhoff's current law, we have VTH minus 6 divided by 2 plus VTH minus 12 divided by 2 equal to 0, because these two currents are living currents and there is no entering current, so is equal to 0. Now VTH by 2 minus 6 by 2 minus 3 plus VTH by 2 minus 12 by 2 we have minus 6 is equal to 0. Moving minus 3 and minus 6 to right hand side, we have VTH by 2 plus VTH by 2 is equal to 9, which is nothing but VTH is equal to 9 volt. Next step is to find the Thevenin resistance. For that we are short circuiting the voltage sources, and the Thevenin's resistance is the equivalent resistance across the terminals A and B. Here the equivalent resistance is nothing but 2 ohms resistors, both are in parallel. So RTH is equal to 2 ohm parallel 2 ohm. So we will get RTH is equal to 1 ohm. As we know that if two resistors of equal values are in parallel, the equivalent resistance will be half of that. So here we have 1 ohm. Now we know the Thevenin voltage is equal to 9 volt and Thevenin resistance is equal to 1 ohm. So the Thevenin's equivalent circuit will be 9 volt in series with 1 ohm. Next question is, read the following statements regarding Thevenin's equivalent circuit. This question was asked in July 2016. So the statements are, Thevenin's voltage is calculated across the short circuit terminals. Thevenin's voltage is calculated across the open circuit terminals. Connection in the circuit is open if any voltage source is present. Connection in the circuit is shorted if any voltage source is present. So the options are A 1 and 2, B 2 and 3, C 1 and 3, D 2 and 4. We know that Thevenin's voltage is calculated across the open circuit terminals and connection in the circuit is short circuited if any voltage source is present. So option D is correct. Thanks for watching the video. If you like this video, click the like icon. For more videos, don't forget to subscribe our channel.